You might have learned how to do differentiation using different techniques, but in this video, I'm just going to focus on differentiation from first principles. Now, I'm going to start by explaining how you differentiate functions like x squared, x cubed. Then I go to how you deal with limits, because when you're doing this differentiation for first principles, at least you need to know where you're going. If you are given a function like y equals x squared, before you do your differentiation from first principles, you may actually know what is the result that you should get. Like now, I'm going to say here, if you have y equals to x cubed, and I say find the derivative of this, which means find dy dx, the derivative of y with respect to x. The answer is 3x squared. If you see what I did, I multiplied by the power 3 and I reduced the power by 1, such that in general, if I'm given y equals to x to the power n, so if I have y equals to x to the power n, it means dy dx, the first derivative of this is n x to the power n minus 1. This is the first derivative. So I multiply by the power and I subtract 1 from the power. If you follow this pattern, it means if you differentiate x squared, that we given here, dy dx, the answer is 2x. That is the answer. So it's quite a straightforward thing to differentiate x squared. Your answer is 2x, but you may be required to use differentiation from first principles. That's what we'll be explaining, how you do it. Even though you know that your answer should be 2x, you still have to show us the steps that you follow when you are using differentiation from first principles. Now, now I have to go to limits, because if you look at this formula, it has this part here, which is about limits. I want to explain how you evaluate limits. If you're given limits, what do you do? That's what I should explain, and the kind of problems that you may face. If I say evaluate the limit as x approaches 2 of let's say x squared plus 3x. This is the limit as x approaches 2 of x squared plus 3x. All you have to do is to substitute 2 for x. That's all. So this means 2 squared plus 3 by 2, which is 4 plus 6. That is 10. That's what you do when you're evaluating limits. You simply substitute this value here for your variable. Like in our case, as h approaches 0. It means every place where there is h, you put a 0. That's how you do limits. But it's not as simple as that sometimes, because sometimes doing the substitution actually creates a problem. Let me show you an example where we face that. Let's say we have the limit as x approaches 3 of x squared plus 4, all of this over x minus 3. If you look at this, if you substitute your 3 for x, you create a problem. Actually, let me not use this one. Let me use a different example. Let me say x cubed minus 27 over x minus 3. If I substitute my 3 for x, the denominator here becomes a 0. And that may create problems because we know that a fraction with a denominator of 0 is undefined. So there are times when this direct substitution becomes a problem. So you have to do some kind of algebraic manipulation or algebraic simplification before you do the substitution. I want to emphasize that part. Let's say we have the limit as x approaches 2 of x squared minus 4 over x minus 2. If we put a 2 here, we get a problem. So what we can do is we can write this as the limit as x approaches 2 of, we factorize the numerator, which gives us x minus 2, x plus 2 over x minus 2. You see, now we can cancel out this. After the cancellation, it means we're just evaluating the limit as x approaches 2 of x plus 2, which is simply 2 plus 2, which is 4. It looked difficult here, it looked impossible here, it looked undefined here because of the denominator. So what we did, we simply factorized and cancelled out. We are going to be doing this a lot when we're doing differentiation from first principles. We are going to sort of like factorize the numerator so that we remove this h from the denominator, because just substituting a 0 for h will create a problem where we have an undefined function. So we try to avoid that. That's the rationale here. Okay, let me take out all this. Let me take out all this. All right. Okay. Now let's continue with our problem. I said we know that our answer should be 2x. We know this, so we don't have a problem with that. So when you are doing differentiation from first principles, all you're doing is finding f of x plus h, f of x, then you substitute into this formula. Then after substituting, you do some algebra, which is essentially factorizing, cancelling out the h, and simplifying. That's all you'll be doing. So let's start. What is our f of x? Our f of x is x squared. According to our question, f of x is x squared. So f of x is equal to x squared. We have this part done. Now let's go to f of x plus h. What this means, if you understand functional notation, it means that every place where there is x in your f of x, you are substituting x plus h, or you are replacing x with x plus h in f of x. So our f of x is x squared. Where there is x, we are putting x plus h. So this is x plus h squared. Now let's simplify this. If we simplify, we get x squared. Let me show. This is actually x plus h times x plus h. If you simplify this, you get x squared plus 2xh plus h squared. This is what you get. Now we have our f of x, we have our f of x plus h. We substitute into this formula here. That's the next step. So let's go to the next step. I'm going to rewrite my formula and do the substitution. I said dy dx is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. I'm going to substitute. This is the limit as h approaches 0. I said this part here is x squared plus 2xh plus h squared minus our f of x, which is x squared. All this over h. If we look at our numerator, x squared will actually disappear. X squared can go. Now let's carry on. So this is the limits as h approaches 0 of 2xh plus h squared all over h. We cannot substitute 0 for h because we will have a 0 in the denominator. That's the only reason we're not doing that. We don't want to have a 0 in the denominator. So to eliminate or to remove this h from the denominator, we're going to factorize the numerator and then cancel out. This is the next step. So the limit as h approaches 0, I factorize the numerator, I take out h, 2x plus h over h. Now with this, I can cancel out my h, which means I'm just left with 2x plus h. That's the next stage. So this is equal to the limit as h approaches 0 of 2x plus h. When we are here, we can now evaluate our limit. We can now substitute a 0 for h because we no longer have h as a denominator. So we can do that. Guys, before you do your substitution, you should keep writing this lim, this part here. You keep writing it until you can now do the substitution. So now we can substitute. And once we substitute 0 for h, we no longer have to write lim. So this is 2x plus 0, which is equal to 2x. We knew already that our answer is going to be 2x. We knew that. But we had to show it by doing differentiation from first principles. I think I should do another question. And I'm going to do it a bit quick, a bit faster. We have y equals to, let's say 3x. Let me say 3x squared plus 2x. Already from here, guys, we know the answer. Our answer should be 6x plus 2. This should be our answer, 6x plus 2. We know it already. We don't have a problem with that. We just have to show it using differentiation from first principles. So let me find my f of x. F of x is 3x squared plus 2x. We know this. It means our f of x plus h. Please pay attention to this part. This is where you go to your function called f of x. Where there is x, you put x plus h. So we have 3x plus h squared plus 2x plus h. I prefer that you do the simplification before you substitute. So do the simplification before you substitute. It's easier that way. So now I know what is inside the brackets. It's x squared plus 2xh plus h squared. I can expand this bracket here and get 2x plus 2h. I can also expand this bracket here. I have 3x squared plus 6xh plus 3h squared, 3h squared plus 2x plus 2h. I don't have any like terms that I can combine. So I should just leave it like this. I should just leave it like this. Then now that I have my f of x, I have my f of x plus h. All I need to do now is to put them in the formula, simplify, cancel out, and then evaluate my limit. That's what I want to do. So let me, so this is 3x squared plus 6xh plus 3h squared plus 2x plus 2h. I'm going to rewrite my formula and do the substitution. So dy dx is the limit as h approaches 0 of f x plus h minus f of x all over h as limit as h approaches 0. Now I'm substituting my values. I know f x plus h is 3x squared plus 6xh plus 3h squared plus 2x plus 2h minus, I'm going to put a bracket here so that I don't confuse my signs. I don't want to confuse my signs. My function, my f of x was 3x squared plus 2x. I close the bracket over h. You check properly if you have done your work clearly. Then so limit as h approaches 0. Now you can simplify the numerator. If you look in the numerator here, 3x squared is going to subtract this 3x squared because there's a minus here, and 2x is going to subtract the 2x. This is what is going to happen. It means the numerator is going to be 6xh plus 3h squared plus 2h. Yes, all of this over h. Still, I cannot substitute my 0 for h. I cannot do that because if I do so, I'll have a 0 in the denominator, and we don't want to have a 0 in the denominator of a fraction because that is undefined. Now, so I'm going to factorize and cancel out. So this is the limit as h approaches 0. In the numerator, I have h as a common factor here. So I can take out h. Then I have 6x plus 3h plus 2, all this over h. Now I have the chance to cancel out. I can cancel out this h. It means I'm just left with 6x plus 3h plus 2. That's what I'm left with. Can I go to the next stage? Make sure you're copying everything that I'm writing. Then I'm going to the next stage. I have limit as h approaches 0 of 6x plus 3h plus 2. Now I don't have any problem with substituting 0 for h. I can now, wherever there is h, I put a 0. And once I do the substitution, I don't have to write the limit anymore. I just write 6x plus 3 divided by 0 plus 2. This is 6x plus 2. This is my final answer. So my dy dx is 6x plus 2. I knew this from the beginning. I knew already that my answer is going to be 6x plus 2. I knew that, but I had to show it using the differentiation from first principles. So you need to master this method, even though you know where you're going, but you should know all the steps that you should go through so that you get your final answer. That's it. If you guys have got questions, you may find that some of the functions that you're gonna be given as your f of x, they will be a bit complex. And when you try to find your f of x plus h, that's where you make mistakes in doing the algebraic simplification and factorization and canceling out. You may make mistakes there. So try to do your work carefully. Try to practice often so that you can deal with any situation that you're given. But that's how you do differentiation from first principles. Thanks for watching the video. If you have any comments, type them below. I will respond. If you have any question, just let me know in the comment section. I will respond to you. Otherwise, thank you for watching the videos.